Gravitation chapter, solution of JEE Mains 2025 January physics questions. Question number 1. Earth has mass 8 times and radius 2 times that of planet. If escape velocity from Earth is 11.2 km per second, the escape velocity in km per second from the planet will be. Suppose this is Earth. Earth की रेडियस r, मास इज m. तो एस्केप वेलोसिटी का फॉर्मूला होता है 2g m/r का रूट एंड दिस इज गिवन 11.2 किलोमीटर पर सेकेंड. प्लेनेट, सपोज प्लेनेट का मास, दिस इज प्लेनेट, mass is m1 and m1 is m/8. The radius is r1 and r1 will be r/2. For planet, escape velocity Vp will be 2g m1/r1 का अंडर रूट. वैल्यूज पुट कर दें हम. 2g m1 is m/8 and r1 is r/2. This is half 2g m/r का अंडर रूट और 2g m/r is VE. half 11.2 5.6 kilometer per second. Option third is correct. Question number 2. Acceleration due to gravity on the surface of Earth is g. If diameter of Earth is reduced to 1/3 of its original value and mass remains unchanged, then the acceleration due to gravity on the surface of Earth is dash g. Earth, इसका mass m, radius r and diameter is d. d is 2r or r is equal to d/2. तो g की वैल्यू, g का फॉर्मूला होता है g m/r², और g अगर d के रूप में लिखें तो r की वैल्यू होगी d/2, इसका स्क्वायर, दिस इज 4gm d². सेकेंड कंडीशन में diameter is reduced to 1/3 and mass remains same. Diameter d1 and d1 is d/3 and mass is m. g dash होगा g m/4gm/d1 का स्क्वायर और 4gm/d1 की वैल्यू पुट कर दी हमने d/3 का स्क्वायर. दिस इज 9 into 4gm/d². फ्रॉम इक्वेशन नंबर 1 दिस इट इज g. तो g dash is 9g. This is 9g. Question number 3. A satellite is launched into circular orbit of radius r around the Earth. A second satellite is launched into an orbit of radius 1.03 r. The time period of revolution of second satellite is larger than the first one approximately by Earth, first satellite launched in orbit of radius r. first satellite. This is R. Time period of first satellite is T1. Second satellite is launched in a orbit of radius r is equal to 1 by 03. इसकी रेडियस है r1 and r1 is 1.03 r. Second satellite, this is second satellite, इसका time period is T2. So according to Kepler's law, T1 का square will be directly proportional to r cube and T2 का square will be directly proportional to r1 cube, और T2 by T1 का square, इक्वेशन 1, इक्वेशन 2, इक्वेशन 1 को इक्वेशन 2 को इक्वेशन 1 से डिवाइड कर दिया, r1 by r का क्यूब, और 1.03 r by r का क्यूब is equal to 1.0927. So T2 by T1 will be 1.0927 का root 1.045. So T2 is 1.045 T1. Percentage larger will be T2 minus T1 by T1 into 100%. 1.05 T1 minus T1 by T1 into 100%. This is 4.5%. Option third is correct. Fourth question. If a satellite orbiting the Earth is 9 times closer to Earth than the Moon, what is the time period of rotation of the satellite? Given rotational time period of Moon is 27 days and gravitational attraction between the satellite and Moon is neglected. Suppose this is Earth, Moon is orbiting in a orbit, its radius is Rm Moon and time period is Tm, and that is given as 27 days. A satellite that is revolving around the Earth in an orbit of radius Rs, and Rs is given as Rm by 9. इसका सैटेलाइट का टाइम पीरियड इज सपोज Ts. According to Kepler's law, Tm square is equal to is directly proportional to Rm cube, and Ts square is directly proportional to Rs cube. So Ts by Tm का square will be Rs by Rm का cube. Rs is Rm by 9 and this is Rm इसका क्यूब, 1.9 का क्यूब, और Ts by Tm स्क्वायर रूट ले दिए, 1.9 की पावर 3 1/2, 1.93 by 2 और 1/27. So Ts will be 1/27 into Tm, and Tm is given 27, so this comes 1 day. Option 2 is correct. Question number 5th. Two planets A and B are orbiting in common star in circular orbit of radii Ra and Rb respectively, with Rb is 2 times Ra. The planet B is 4 root 2 more massive than planet A. The ratio angular momentum of B divided by angular momentum A of momentum of LB and planet B to that of planet A is closest to the integer. RB is equal to 2 RA and MB is equal to 4 root 2 MA. LA, MA, VA, RA, MVR, MA, VA is GM upon RA का रूट. M is mass of that star into RA, or MA into GM RA का रूट. This is LA, and similarly LB will be MB GM RB का रूट. तो LB by LA, MB by MA into RB by RA का रूट. MB is 4 root 2 MA upon MA, and RB is 2 RA. This is 4 root 2 into root 2, this is 8. तो जो रेशियो आएगी that will be 8. Question number 6. A small point of mass m is placed at a distance 2r from the center O of a big uniform solid sphere of mass m and r. The gravitational force on m due to capital M is F1. The spherical part of radius r by 3 is removed from the big sphere as shown in the figure, and the gravitational force on m due to remaining part of m is found to be F2. The value of F1 by F2 is F1 G m into distance का स्क्वायर r का स्क्वायर GFF by 4 r square. F2 will be force due to whole sphere minus force due to removed part. फोर्स एक्ट करेगा एम पर, जो होल पार्ट है उसके कारण फोर्स, एंड माइनस कर दें हम जो डिडक्ट किया है, तो जो होल पार्ट के कारण जो फोर्स है दैट इज F1, and suppose this is F dash. F1 GMM by 4R स्क्वायर माइनस इसकी डिस्टेंस होगी यहाँ से R1, and R1 will be R by 3, 4R by 3. सपोज रिमूव्ड पार्ट है उसका मास इज M1, तो M1 बाई M ये वॉल्यूम की रेशो में होंगे 4/3 पाई R1 क्यूब अपॉन 4/3 पाई R क्यूब, क्रॉस हो गया, R1 इज 4R/3 का क्यूब अपॉन R का क्यूब, 64/27, M1 is 64/27 M. G M one M by R1 square. G M by 4R square minus G M1 is 64/27 M small m upon R1 is 4R/3 का, this is square. तो F2 GMM by 4R square minus GMM by R square into 64/27, 16/9. GMM by 4R square minus GMM by R square into 4/3. This is M1 is R1 is this radius को अगर हम R1 डैश से नोट करें तो R1 डैश विल बी R/3, दिस विल बी R1 डैश, तो R1 डैश क्यूब बाई R की पावर 3, R1 डैश इज R/3 का क्यूब बाई R क्यूब इंटू M/27, दिस इज M1 होगा M/27. (27) 1/27. (1 by 48). 48 R square 12 minus 1 GMM 11 by 48 GMM by R square. This is F2. F1 ratio F2, F1 ratio F2, F1 is GMM by 4R square and F2 is 11 by 48 GMM by R square, or 48 by 11 into 4, 12 by 11. So F1 ratio F2 is 12 ratio 11. Option first is correct. Question number 7. A satellite of mass m by 2 is revolving around Earth in a circular orbit at a height of r by 3 from the Earth's surface. The angular momentum of satellite is m by m under root gmr upon x with the value of x, where m and r the mass and radius of the Earth respectively. G is gravitational constant. This is Earth, radius r, mass is m. Its satellite is orbiting at a height of h. This is h is equal to r by 3. The total distance, this small r, will be r plus h, r plus r by 3, 4r by 3. Satellite orbiting. ऑर्बिटिंग सैटेलाइट की जो वेलोसिटी होती है v इज gm बाई स्मॉल r का अंडर रूट और gm बाई 4r बाई 3 का अंडर रूट और 3gm बाई 4r का अंडर रूट. दिस इज v. एंगुलर मोमेंटम L, इसका मास ऑफ सैटेलाइट का मास m is m by 2. mv into r, m by 2 into v is 3gm by 4r का अंडर रूट and small r is 4r by 3. m by 2 into 4gm by 3r का अंडर रूट और m by 2 into 2 gm by 3r. GMR और m अंडर रूट GMR by 3, and this is given as m GMR by x का अंडर रूट. कंपैरिजन करेंगे तो x इज इक्वल टू 3, x की वैल्यू इज 3.